Hello, statistics sleuths. Today we'll be dealing with the culprit known as the independent samples t-test. My name is Detective Leah Shull, and I'm here to explain to you what an independent samples t-test is and how to perform that test in SPSS. What is an independent samples t-test? It is a way to compare the means of two different groups to determine whether the means of those groups are significantly different. This is an inferential statistic, which is different from a descriptive statistic. While a descriptive statistic tells you what is going on in the data you have already collected, an inferential statistic allows you to generalize to a larger population with certain limitations. Today I'll be sharing an example of how you might use this test in education. As our sample data set, I have collected the benchmark data from one of my 6th grade language arts classes and also the benchmark data of my colleague who also teaches 6th grade language arts. I'm looking to see if there is a statistically significant difference between her students and my students on the percentage of correct answers on our most recent benchmark. So I've opened up my sample data set in SPSS, and now we need to figure out how to use the independent samples t-test. So the first thing we're going to do is come up to this Analyze tab and come down to where you see Compare Means, because that is what this test does. It is comparing the mean of one group to the mean of another group. In this case, it's the students in my class to the students in another class. So then after we've clicked compare means, you'll see this box appears showing you the different tests that you can run. And we are going to run the independent samples t-test. When you click on that, you'll get this dialog box and you'll need to move over into the test variable column, whatever it is that you're trying to test. In our case, this is the percentage correct. And down in the grouping variable, you're going to put how you're deciding your groups. So in my case, I've given all the students in my class the code of 1 and all the students in my colleague's class the code of 2. And you do have to define those groups. I've already done this, but you see how you have to put group 1 and give that person or that group a number, and group 2 needs a number also before it'll let you continue. When you click OK, you'll get your output. Now this output gives us a lot of information. The first box up here gives us our group statistics. So it has broken it down by the percentage correct for class 1, which would be my class. It tells us that there were 26 students in the sample and that the mean was 51.6 with a standard deviation of 16.16 and a standard error mean of 3.17. My colleague's class also had a sample size of 26. Their mean was 49.02 with a standard deviation of 18 and a standard error mean of 3.6. Now most people could look at these two means, 51.6 and 49.0, and tell that those are different numbers. But the question we want to answer is that a significant difference? Is it statistically significant? And for that, we'll use the rest of this information that our output has given us. So we are going to read the top line of this test. And when we come over here, this significance, that is giving you your p-value. So we see that this test has given us a p-value of 0.582. And as you probably recall, the significance factor that we're looking for is a value that is lower than 0.05. So this number, 0.582, is obviously higher than that, meaning that there is no statistically significant difference between my class and my colleague's class. But we also want to look at the t-value. So the t-value here, and the t-value is going to tell us whether we need to accept or reject the null hypothesis. So we see that we have a t-value here of 0.554. And what do we do with that number? Well, you're going to need to use a t-chart, a t-values chart. And our statistics textbook conveniently had one of these located in the back. And if you happen to have Statistics for People Who Think They Hate Statistics by Neil Salkind, the 6th edition, you'll find this handy text or table on page 403. T-values needed for rejection of the null hypothesis. Now, there are a lot of different values on this table, so how do you know which one to use? Well, you're going to look at this DF. That DF column is the degrees of freedom. So the degrees of freedom in our case is 50, and when we look up the corresponding value on the table, we see that using our significance level that we want to use, which is 0.05, and in using a two-tailed test, because this could be either her class did worse or better, so that makes it a two-tailed test, that the value we would need to reject the null would be 2.009. So our value, our t value, would have to be higher than 2.009 in order for us to reject the null. And as you can see clearly, our t value is 0.554, significantly lower than that threshold that we would need to reject the null. So even though we didn't specifically say this at the beginning of our little video here, our null hypothesis is that nothing is going on, that there is no statistically significant difference between my class and my colleague's class. And as we've seen, the t-value supports that null hypothesis. We do not have enough evidence to reject the null. So thank you for watching Statistics Sleuths. I hope that you learned something today, and I hope that this helped unmask the independent samples t-test for you.